Okay, so if we're using if we have the quadratic function, it has real roots x1 and x2. With x1 less than or equal to x2, use the quadratic formula to show that. Okay, so if x1 is less than x2, we're going to have x1 is negative b minus the square root of b squared minus 4ac all over 2a. And we're going to have x2 is equal to negative b plus the square root of b squared minus 4ac all over 2a. Now, if we add these together for I, we're going to have negative b minus square root of b squared minus 4ac all over 2a plus negative b plus root b squared minus 4ac all over 2a. So we're going to have negative b plus negative b, which is negative 2b. And the negative root b squared minus 4ac cancels out with the positive root b squared minus 4ac. And those are both over 2a. So the sum of the roots is negative b over a. If we do x2 minus x1, we're going to have negative b plus square root of b squared minus 4ac over 2a minus negative b minus the square root of b squared minus 4ac over 2a. And if we do negative b minus a negative b, remember this is subtracting this whole thing, the b's will cancel. And if we do b squared, root b squared minus 4ac minus a negative root b squared minus 4ac, that's going to be 2 the square root of b squared minus 4ac over 2a, so that cancels, and that's the square root of the discriminant over a. All right, for triple I here, if we do x1 times x2, we're going to have negative b plus square root of b squared minus 4ac all over 2a times negative b minus b squared minus 4ac over 2a. Okay, so we are going to have it's over 4a squared, and then we have to distribute this top. So we've got negative b times negative b is b squared, and then we're going to have plus b root b squared minus 4ac, and then we're going to have this to this, which is minus b root b squared minus 4ac, and then we're going to have minus root b squared minus 4ac times root b squared minus 4ac, which is b squared minus 4ac, all of that. So now the b squareds will cancel, this will cancel, and we're going to have a positive 4ac over 4a squared. The 4's cancel, 1a cancels, so we have c over a. Okay, so for b, find the sum of the roots. We're going to have the sum of the roots, x1 plus x2, we showed is negative b over a. So we're going to have negative 10 over 1. So negative 10 is the sum of the roots. For c, I find in terms of k the product of the roots. Well, we've got the product, x1 times x2 is c over a here. So we're going to have k over 1. Okay, so k, that's the product of the roots. And the distance between the x-intercepts, which is x squared minus x1. And we're going to have the square root of the discriminant, which is b squared minus 4a c all over a, which is 1. So we're going to have this is equal to 100 root 100 minus 4k. Okay, so for D, find the possible values of k for each of the following cases, given the quadratic has two distinct negative roots. Okay, so first, for D, if it has two distinct negative roots, if it has two roots, we've got that the discriminant is greater than 0. So b squared minus 4ac is greater than 0, so 100 is greater than 4k, so k is less than 25. All right, so that's one thing, but if it has two distinct negative roots, the sum of the roots, that has to be less than 0, and the product of the roots, so the sum is negative b over a is less than 0. So, and the product of the roots has to be greater than 0 because two negatives multiplied makes positive. So c over a is greater than 0. So for this one, we have that. Yeah, we don't actually, the sum one doesn't really help us out because we need to find k. So we've got k over 1 is greater than 0. So if we multiply by 1, we have k is greater than 0. So we've got k is greater than 0, but less than 25 for that one. Okay, so for double I, sorry, this is all over the place. Given that the quadratic has one positive and one negative root. Okay, so we have that x1, x2 is less than 0. And still k is less than 25. So we have c over a is less than 0. So k over 1 is less than 0. K is less than 0. So it'd have to be the intersection of those. So 25 is here. This is less than 25. If 0 is here, it has to be less than. So what satisfies both of them? Well, less than 0. Okay? Okay, consider the graph G of the function f of x equals x squared and the point M 5, 2 on the Cartesian plane. Find the coordinates of a point A on G and a point B on the x-axis, given that M is the midpoint of the line segment AB. So I've drawn the situation out. If we have just some general point on this graph, wherever, it can be here, it doesn't matter where. So if we want to find the coordinates of a point A, so this is A, this is the graph G, and a point B on the x-axis, so the point B on the x-axis is going to be x0. So M is the midpoint, so this is 5, 2. So we're going to have, and we should probably do x1, y1, and x2. So we're going to have x1 plus x2 over 2, and y1 plus 0 over 2 equals 5, 2. Okay, the midpoint. So, yeah, we would have x1 plus x2 over 2 equals 5, and y1 over 2 equals 2. So we can see y1 is 4. And then if y1 is 4, that is on the graph G, which is y equals x squared. So if we have 4 here, we can see that x, if we solve this, x is going to be plus or minus 2. So we will have so basically we have the point 2, 4 and negative 2, 4, which actually is here. I drew those. And here. And if we have that, then we have two cases here. So, you know, this could be x1 or this could be x1. So we have 2, if x1 is 2, I have 2 plus x2 over 2 is 5. So that would mean x2 is 8. So if that's the case, 5, 6, 7, 8. So here we go. So this is the point 2, 4. And if that's the point on G, the point on the x-axis is going to be 8, 0. So you can see that M is the midpoint there, okay? For the case if x is negative 2, so this was when x1 was 2, if x1 is negative 2, we're going to have negative 2 plus x2 over 2 equals 5, and then we'd have x2 is 12. So in that case, we'd have 8, 9, 10, 11, 12 here, and that would be the midpoint of those two. So if we connect, so I connected those, and that is the midpoint, and this is the point, negative 2, 4. Okay, so sometimes you just have to start somewhere with these. So for B, find the coordinates of a point C on G, given that the distance between M and C is 23. So if we have, again, just a random point C, we'll say, again, x1, y1, and we have the distance between M and C is 23. All right, so this one's a bit more straightforward, I think, because we'll have the distance formula, and we have x1 minus 5 squared plus y1 minus 2 squared, and that will equal 23. Okay, so if we square both sides, that's going to be x1 minus 5 squared plus y1 minus 2 squared equals 529. And then I'm just going to drop the ones, but that's going to be x squared minus 10x plus 25, and that's going to be y squared minus 4y plus 4 is 529. So, yeah, we have two variables, but we do have the function. So what we can do, instead of using y, we can use the fact that y equals x squared. So, all right, so we're going to have x squared minus 10x plus 25 plus x squared squared minus 4x squared plus 4 equals 529. And then we're going to have x to the 4th minus 4x squared plus x squared is minus 3x squared. And then we have minus 10x 25, and 4 is 29, and minus 500, 29 is minus 500 equals 0. This, you can use a graphing calculator, so I just used that menu 331 and changed it from degree 2 to degree 4. You can also graph it and find the x-intercepts, but you get that x is negative 4.78, or x equals 5. So that is what x equals, and we would just need to square each of those. So because remember, these are points on the graph. So this one's going to be 525. And if we square negative 77688, that's what it is in the calculator squared, that's going to be 22.8. Okay, so those are the points on the graph that if you graph them, you know, it's way up there, they would have a distance of 23 from M.